Okay, today we're going to look at, first of all, even and odd functions. Now, much of this stuff is going to be ideas that we've repeated earlier, that we've had earlier. For instance, the case of an even function says that f of minus x is minus f of x. The easiest way to look at that is to do our old friend, the parabola. F of x is equal to x squared. So this is my function. Now look what that says. Let's use numbers. F of 2 is 2 squared, which is 4. So when I put in 2, I got out 4. F of minus 2 is minus 2 squared, which is still 4. So I put in minus 2, and I still get out 4. So an even function, when it is truly even, is going to be symmetric to the y-axis. Now, let's look at it from a graph. 0, 0, 1, 1, 2, 4. So that's that half of that parabola. This is the other half of the parabola. So if it is a truly even function, the y-axis is going to be the symmetry. And the test says that you replace a minus x with an x and it stays the same. Well, if I take my original equation, f of minus x is minus x squared, but minus x squared is x squared. So f of minus x comes out to be x squared, just like f of x is equal to x squared. That's honestly your test for an even function. Okay, an odd function says that f of minus x is minus f of x. The easiest one for me to give you for that one is our old friend, the cubic function. That's a real good odd function. Okay, so let's try it with numbers. F of 2 is going to be 2 cubed, which is 8. F of minus 2 is minus 2 cubed, which is minus 8. The graph of it is interesting. We've already had it. The graph of it looks like this. So if this point right here is 1, 1, there's a point down here, minus 1, minus 1. If this point is 2, 8, there's a point down here, minus 2, minus 8. I want you to notice the midpoint between 1, 1 and minus 1, minus 1 is the origin. That's what makes it an odd function, which also makes it origin symmetry. 2, 8 and minus 2, minus 8. The midpoint between those 2 points is still the origin. So if it is a truly odd function, then it's going to have origin symmetry. And when you put in a positive value for x and you put in a negative value for x, you're going to go from the positive y to the negative y. Now, your book gives you a couple of them and he says, are these even, odd, or neither? So if I give you y is equal to x to the 4th, then that would be an even function. If I give you y is x to the 5th, that would be an odd function. Now, but be careful. If I give you y, just this simple, x squared plus 4x, then that is not even nor odd. And we say it is neither. I think it'd be interesting for us to get a little bit ahead of ourselves and look at the graph of this x squared plus 4x. So when x is 0, y is 0. And when x is minus 4, y is also 0. So if I draw this graph, it's going to have that U-shaped curve. Now, it does not have y-axis symmetry, so that means that it's not an even function. And what made it not an even function is that you had one power of x that is even, but you have another power of x that is odd. Now, don't fall for the trap. If he gives you one like this, x squared plus 4, that's still an even function because it doesn't have a power of x that is odd. If you look at it from a graph standpoint, this is x and this is y. So your y-axis is still your axis of symmetry. in this section, he also keeps talking about interval notation. So if I give you this, 3 is less than x is less than or equal to 5. If you're going to write that as an interval, you're going to write it as 3, 5. Now, let's remember what we said earlier. The parentheses says that it's not included, it's not less than or equal to. The bracket says that it is included because it was less than or equal to 5. I'm going to go back to, I told you the other day we were going to use this. This is a graph that we had the other day. And this is -6, -3, -3, 0, 0, 3, 2, 4, 4, 3, 5, 0, 8, -2, and 10, 0. Now notice that I didn't give you an equation for this graph. The equation is not what's important. What we do with this is what's important. And I think I had this point over here, 11, 1. Now, the fact that I stop it there is going to be important, the way we answer some of these questions. Okay, number 1, is it a function? And the answer is yes, because if you did the vertical line test, any vertical line that you would draw would hit this graph only one time. So it is a function. It passes the vertical line test. And we can answer several questions off of it. We answered one the other day. How much would f of 2 be? Well, you simply look at your graph. When x is 2, y is 4. So f of 2 would be 4. Suppose that I told you that f of x was equal to 1. So I'm telling you the y value is 1. You look at your graph, and when y is 1, x is equal to 11. So in that particular case, all we're doing is simply reading from the graph. Okay. Today, we want to talk about where a function is increasing and decreasing. And let me, very important. You're always going to move left to right to talk about increasing and decreasing. So if you look at this mess right here, this curve is increasing, and it increases all the way up to 4. Now at 2, 4, something happens, it turns, and it comes back down. So it is decreasing from 2, 4 down to 8 minus 2. And then it is increasing again from 8 until 11. Now, when we talk about increasing and decreasing, we're always going to talk about it on an interval. So in this particular case right here, I want to know what's happening on the interval from x is -6 to x is 0. I want to know what's happening to that curve from this point to this point. Well, it's easy to see. It is increasing. Okay, what's happening on the interval from x is 2 to x is 8? Well, from x is 2 to x is 8, this curve is decreasing. Now, what happens on the interval from 8 to 11. And I want you to notice I'm simply using the x values. Well, on the interval from x is 8 to 11, this curve is increasing. So the idea of a curve increasing and decreasing is very easy when you got the graph to look at it. And I want you to say, I'm going to say it one more time. You always look from the left to the right. So the left value of x is 8 to the value of x is 11. This curve is increasing on that interval. Okay. Now, another interesting idea is rate of change on an interval. Okay, on my graph back there, let's go on the interval -3 to 2. Well, the rate of change is really the same thing as the slope. Now, I want you to keep that in mind. The rate of change is the same thing as the slope. Now, we had a formula for slope. The slope is y2 minus y1 over x2 minus x1. So I wanted to find the rate of change from x is 3 until up until x is equal to 2. So my first point was 0, 3, and my second point was 2, 4. And let's keep in mind what we just said. I had a point 0, 3, and I had a point 2, 4. All right. So it's y minus y, so that's going to be 4 minus 3 over x minus x, which is 2 minus 0. And that gives me 1 divided by 2. Now, this is important. Look at it. The fact that that come out to be a positive 1/2 simply saying that it is increasing, and that's what we found just by looking at that graph. So from the point 0, 3 to the point 2, 4, this curve had a positive rate of change, which simply means that it was increasing. All right, let's do it on another interval. Let's do it from 4, 3 to 5, 0. Let's go from 4, 3 to 5, 0. All right, we want to find the rate of change. So it's going to be 0 minus 3 divided by 5 minus 4. This comes out to be minus 3 over 1, which is minus 3. Now, that's important because when the rate of change is negative, that says that the curve is decreasing. Well, when we looked at that, if you look at that curve back there, you'll find on that interval, it is decreasing. So please, the rate of change is nothing but the slope on a particular interval. Now we have to be very careful with what interval we talk about. Let's look back at our graph here. I wouldn't talk about the rate of change from 0, 3 over to 4, 3 because something happened at 0.24. Now, 0.24, this is what we call a local maximum point. In other words, it is a highest point on the curve. This point 8 minus 2 is what we call a local minimum. It is the lowest point on the curve. We can answer those same questions that we asked the other day for this particular thing. Let's look at the domain. Well, the domain is a set of x values. I went from x is minus 6, all the way over to x is equal to 11. So the domain of this particular function is minus 6 to 11. All right. Since we got the graph, we can also talk about the range. The range is a set of y values. Well, look at it. The lowest y value is -3. The highest y value is 4. So the range of this thing is from -3 to 4. The range is a set of y values, and the domain is a set of x values. And for some crazy reason, he goes back to a topic that we had earlier, so let's go ahead and do one. He asked me to find the equation, and very important that he tells you that it's a line through 3, 4, and he gives you a slope of 2. So he gives you this bit of information. I want to find the equation of the line that'll go through 3, 4 and have a slope of 2. Every time he hollers the equation of a line, this is the formula that we're going to use. So we plug in y minus 4 is the slope times x minus 3. So this would be the equation of that line. Now, it depends upon which way he wants you to leave the answer. And I noticed on the test that he lets you leave it in this form right here. That's kind of odd that he would do that, because normally what we do is do the arithmetic that we can. So to me, a better answer would be 2x and bring the 4 over, and it'd be -2. And the reason that that's better, because we now have it in the explicit form. You can put that into your calculator, and you can see that it's going to have a slope of 2. Now, if we look at this thing from a graph standpoint and talk about this increasing and decreasing. So when x is 0, y is -2. Oh, let me put him here. 0, -2. Now, and when y is equal to 0, x is +1. But look at this line. It is increasing. It is increasing because the slope of this line is 2. It all makes sense. Every time the line is increasing, it has a positive slope. And when the line is decreasing, it will have a negative slope. Okay, this is just like one we looked at a while ago. He could ask 2 or 3 questions about this. Number one, is it odd, even, or neither? Well, the answer is it is neither, because it has an even power of x, but it also has an odd power of x. Another thing that he could easily ask for are the intercepts. So if I let x be 0, 0, 0, my y is going to be 0. Now, if I let y be 0, and this is something I found that we have a little bit of trouble with. I let y be 0, and I want to solve this for x. Well, the easy way to solve that is to factor out an x. So I get 2 values. X is 0, and x is -1. Now, I just can't resist to going ahead and put it on a graph to let it make a little bit of sense. So when x is 0 and x is -1, and we know it's going to be the U-shaped curve because of the fact that it is x squared. So the y-axis is not the symmetry, and that's the reason that we ended up with this thing here that is neither. It's neither even nor it's odd. Now, I'm not discounting symmetry. We're going to talk about symmetry later on, and we'll find that this thing does have a line of symmetry, and it goes right down through the middle of that parabola. But that's for another day. And okay. Okay, get us a new equation. Okay, so I think it's time that you drug out that calculator and you draw you a couple graphs using that calculator. Now, I'm going to cheat on this thing right here because I designed these numbers so that they come out real convenient for me. But when you draw this graph, you're going to find that when x is 0, y is going to be 2. And you're going to also find that when x is 2, y is going to be minus 2. Now, I cheated a little bit to get those points. But the important thing is that you're going to draw your graph with your calculator and you're going to find those 2 points. Because you've got a problem just like this come test time. Now, keep in mind that this thing was that cubic equation. That's going to give me that S-shaped curve. And these 2 points that I just found are very important because this is a max and this is a min. So now he's going to ask those same questions that we did a while ago. Where is this curve increasing? Well, it's increasing on the interval from negative infinity up to 0. Now, I want you to notice that I put the 0 in the parentheses, not in the bracket, because something happened at 0. This curve is also increasing from 2 to positive infinity. It is increasing on this interval here. Now, I think it's kind of obvious that between x is 0 and x is 2, this curve is decreasing. It's decreasing on the interval from 0 to 2. Now, notice when I talk about an interval, folks, we're using the x values. So this first one, we start way down here at negative infinity, and we go all the way up to 0. Over here, we start when x is 2, and we go to positive infinity. It is decreasing on the interval from x is 0 to x is equal to 2. Okay, let's take this same graph and let's get the rate of change, and let's use one that we can easily see right here. Let's get the rate of change from the point 0, 2 to the point 2 minus 2. All right, the rate of change is the same thing as the slope. So that's going to be 2 minus 2, y minus y over x minus x, which is going to give me 4 divided by negative 2, which is negative 2. Now, it's very important. Look at it. My rate of change came out to be negative. What is my curve doing between the point x is 0 and the x is 2? Well, it is decreasing. Okay, look at this thing. This is a truly even function. And it's a truly even function because all the powers of x are even. So that means that it is going to have y-axis symmetry. Now, once more, you're going to draw this graph on your calculator. Now, I'm going to cheat a little bit. I'm going to get down here and do a little bit of arithmetic that I'm not going to show you. Okay. So something happens at this graph at x is 0, and when x is 0, y is 4. Very, very important point. When x is 0, y is 4. Now, also when x is 2, that's going to give me minus 16 plus 2 squared is 4 to make 32, and then plus 4. So when x is 2, y is going to be 20. So when x is 2, y is going to be 20. So that means that when x is minus 2, y is also going to be 20. Okay. Now, I want you to notice this thing. This thing gives me that W-shaped curve. That x to the 4th is what makes that W-shaped curve. Now, the fact that it's a truly even function says that the y-axis is symmetry. Well, forgive my sloppiness, but we can see that this thing would fold over on the y-axis. And then he can ask all these same questions that he's been asking. This thing is going to be increasing on this interval. It's going to be decreasing on this interval. It's going to be increasing on this interval. And it's going to be decreasing on this interval. Once you get the picture, the graph, then deciding whether it's increasing or decreasing is a really easy thing. But now, since we've got us a couple good points here, let's do it. Let's do it. Let's do the rate, and let's do it from 0,4 to 220. So it's going to be 20 minus 4 over 2 minus 0. And that gives me 16 divided by 2, and it gives me positive 8. So, and that's exactly what this graph shows me right here. On the interval from 0,4 to 220, this thing has a positive rate of change, and a positive rate of change says that it is increasing. Okay, this next section, I'd like for you to put this on a page that you can readily refer back to it. And this is 4.3.4. And this is what we call a family of graphs. In other words, these are graphs that we use so often that we really should have the basic idea of what they look like memorized. Well, one of them we've already had. Let's just use it. Y is equal to x squared. We know what y is equal to x squared looks like. That's my U-shaped curve, all right? Let's say y is equal to the cube root of x. Well, when x is 0, y is 0. When x is 1, y is 1. When x is 8, y is 2. I'm careful, I'm simply using numbers that we got memorized. Now, but the graph points out to what we've already said. This is an odd function. Cube root of x is an odd function. So that means it's going to have origin symmetry. And it certainly does. This point right here is a point 1, 1. This point back here is a point -1, -1. This point back here is a point -8, -2. So from 8 to 2, back to -8, -2, the midpoint is going to be the origin. So that's another one that we use real often is our old partner, the square root of x. Well, the square root of x is really just a sideways parabola. So the square root of x is going to look like this. 0, 0 is a point. I'm exaggerating so we can see it. 1, 1 is a point. And then back over here, 4, 2 is a point. So it is a parabola that lays sideways. Now I want you to notice that I didn't draw the bottom half of this thing. Because if I were to draw the bottom half of it, I wouldn't have a function because it wouldn't pass the vertical line test. Now we've already done the cubic function, but let's do him one more time, make sure that we have it. So y is equal to x cubed looks like this. This is the 0.11. And this is the 0.28. This is the point minus 1 minus 1 minus 2 minus 8. Okay, there's another instrument that we look at, and I think we did it the other day, and that's the absolute value function. Now, I want you to watch what happens when you draw this graph. 0, 0, 1, 1, 2, 2. Now, every time you draw the absolute value function, you're going to have this V-shaped curve. Keep that in mind. Absolute value function, you're going to have the V-shaped curve. Okay. The next thing is something that people don't like. I'm not going to lie to you. And he talks about a piecewise function. Don't make it complicated, folks. All in the world we're doing is drawing 2 or 3 graphs on the same axis. And he even tells me what domain to use. For instance, he tells me that f of x is going to be equal to, and let's say, I'm going to use x squared if x is greater than 0. I'm going to use minus 3 if x is equal to 0. Let me change this one right here. If x, I'm going to use x squared for anything less than 0. I'm going to use minus 3 at 0. And I'm going to use 2x plus 3 if x is greater than 0. Now, please, all in the world he's doing is giving you 3 separate graphs, but he's telling you what the domain is. So y is equal to x squared. Well, y is equal to x squared is this graph, but he says you're only going to use x values that are negative. So we're going to erase this part of the graph. Now, he said when x is 0, y is minus 3. So 0 minus 3, that's important. In other words, this graph comes up here like this. Now, this is a hole in the graph right there because at minus 3, he told me we're going to, at 0, we're going to let y be minus 3. That's simply the way he defined it. Now, notice what happens right here. He says, when I use positive values of x, I'm going to draw this line. Well, when x is 0, y would be 3. That would be this point right here. Now, when x is 1, y would be 5 and 2 and so forth. So that would be this graph. Now, I want you to keep in mind that this is a hole right here because we've already said that when x is 0, y is going to be minus 3. In that line up there, if I use that point 0, x, y is going to be positive 3. This whole idea is this, folks. A piecewise function, if he says he's going to give you 2 or 3 graphs, you're going to put them on the same chart, but he's telling you what you're going to use for your domain. And you only use the x values for that particular graph that he specifies. And that's the whole idea between a piecewise function. I want you to keep in mind that we've done section 3 and 3.4 today. So that means that we've already covered sections 1, 2, 3, 1, 2, 3. So it means Monday night, you can take your quiz, your next quiz, which is going to be covered by these sections. Good luck.